Hello. Today we're going to take a look at how another algebra technique intersects proving trig identities. We're going to look at using the conjugate. Let's go. So here's the identity we're going to work with today. And as you know, when we prove an identity, we only work with one side. So we say work with the more complicated side. I would say in this case, either of these could count as the more complicated side. Over here, we have a squared. Over here, we have a fraction. For the purpose of this video, I'm going to teach you a trick you can use when you're looking at a fraction like this. All right, so on the bottom of my fraction, I have secant x minus tangent x. Over on this side of the equation, I see I have a secant squared. So eventually, I'm going to need to get some squareds in there. So here's the algebra thing I want to remind you of. The conjugate. The conjugate means that if you have one term minus another term, you would multiply top and bottom by one term plus the other term. And vice versa. If this had said plus, you would multiply by one term minus the other term. So let's see what that looks like here. Okay, so I've got my initial left side, and I'm multiplying top and bottom by the conjugate of the denominator here. That means same terms, but a plus between them. Why can I do this? Anything over itself equals 1, right? And if I multiply by 1, I keep everything the same. So on the top, if I multiply this through, I get secant squared x plus secant x tangent x. That looks extremely exciting, except I still have this denominator, so let's see what happens here. The whole reason we're multiplying by the conjugate is we eliminate the middle term, right? Secant x times secant x, secant squared x. Then I have secant x times negative tan x and secant x times tan x. Well, minus sec x tan x plus sec x tan x is 0. That goes away. And next time you do this, you don't even have to write that step. And finally, tan x times negative tan x squared. Okay, now you're saying, well, hey, I just want the numerator. I still have stuff on the denominator. All right, don't panic. Let's remember, secant squared x is part of a trig identity. It equals 1 plus tan squared x. And then when we bring down that minus tan squared x, well, 1 plus tan squared x minus tan squared x is just 1. This whole denominator becomes 1, which means we have just proved our trig identity. Okay, so that is a reminder of how to use the conjugate to take a denominator, turn it into a difference of squares, and then use substitution to simplify or even, in this case, eliminate it. All right, take a look at my trig playlist. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.